Let's do a word problem because there are some in the homework. A company buys a machine that it thinks is going to generate revenue. It's also going to cost money to operate and maintain the machine. And the company estimates that T years after the purchase of the machine, it'll be generating revenue at the rate of R of T equals 655,000 minus 8,000 T squared, that's in dollars per year. And the cost of operating and maintaining the machine will be C of T equals 15,000 plus 2,000 T squared, and that's also in dollars per year. The company's going to operate the machine until the time when the maintenance and operating costs equal the revenue it generates. In other words, the anticipation is that the revenue is going to be going down and the costs are going to be going up as the machine ages. And we can see this just from a rough graph. I mean, the problem doesn't ask us to graph this, but for me it tends to be helpful to get some kind of visualization of what's going on. Notice that revenue function is a parabola because of the t squared. The parabola is opening downwards because the coefficient on the t squared is negative. And again, I don't really care exactly what this looks like. It's just something like that. And I can be a little more specific. I can see that if I plug in a t equals 0, that second term is going to go away, leaving me a y-intercept of 655,000. This is our revenue function. And the cost function is also a parabola because it's also got a t squared term. That parabola is going to be opening upwards because the coefficient on that t squared term is positive. And again, I don't care exactly what this looks like, just some parabola opening upwards. And I can see the y-intercept is at 15,000 because if we were to put a 0 in for t, all that would be left would be 15,000. So indeed, we can roughly see that, yeah, the revenue is going to be going down, the cost is going to be going up, and at some point those two curves are going to intersect, and at that point the revenue will be equal to the cost. And that's when the company is going to stop using the machine. When it starts costing more to operate than it's bringing in revenue. So for part A, how long will the company use the machine? It's going to use the machine until C of T equals R of T. So we need to solve $15,000 plus 2,000 t squared equals 655,000 minus 8,000 t squared. Let's add 8,000 t squared to both sides. On the left-hand side, that'll give us 10,000 t squared. And let's subtract 15,000 from both sides, which on the right-hand side will give us 640,000. Oh, and I see I forgot a 0 in the first line. There we go. Next, we'll divide both sides by 10,000, which will give us t squared equals 64. So t would be plus or minus 8, but we're only interested in positive t values. Right, because t is representing how long after the purchase it is. And we can't go back before the purchase. So the t we're interested in is positive 8 years. What will the total profit produced by the machine be during the time the company uses it? Well, profit is revenue minus cost. That again is going to be in dollars per year because both revenue and cost are in dollars per year. So this is a rate of change of profit. yearly change in profit. Anyway, the total profit then will be the definite integral of that rate of change. And again, that's computed by going revenue in dollars per year minus cost in dollars per year. What are our limits of integration? Well, it starts at the time of purchase, because that's when presumably the company starts using it, and it ends when the company stops using it, which we just said was in 8 years. Let's put in what our revenue and cost functions are. 655,000 minus 8,000 t squared minus the cost function, 15,000 plus 2,000 t squared dt. If we distribute into the parentheses and combine like terms, I hope it's okay with you guys if I combine that in one step. Anyway, we'll get 640,000 minus 10,000 t squared. Remember, I distributed this minus sign into the parentheses. Our antiderivative then is 640,000 t minus 10,000 t cubed over 3, going from 0 to 8. Plugging in our limits of integration next, we have 640,000 times 8 minus 10,000 over 3 times 8 cubed minus what we get putting in zeros, which is just zeros. So we wind up with $3,413,333.33.